From the moment I understood the weakness of my flesh, it disgusted me. This is Clanker 907, a mere prototype, step 0, baby, innocent. Every limb of this abomination is controlled by a neural network. Gentlemen and ladies, this is Cosmos, and it is time for an open brain surgery. So, what is a neural network? I like to think of it as a mathematical function. You give it inputs and get outputs. But instead of a simple equation, you have a more complex matrix. The more nodes, the higher the IQ of the AI. Today, we're gonna be attempting biomimicry and use two neural networks, one for locomotion and the other for navigation and hunting. Separate modules for their own tasks, just like the brain does it. So, what observations does an organism need to be able to walk? Well, self-awareness is priority. We begin by extracting the position, rotation and velocity of every limb and feeding into the neural network. That is proprioception, and is precisely why you can touch your nose with your eyes closed. Each limb is bolted with a ground contact sensor. We can exploit its Boolean nature to penalize any ground collisions, thigh and up. This forces the AI to stay on its feet. Ladies and gentlemen, the Clanker finally understands it exists. Now, we give it a reason to suffer. Monkey need banana, and so does our AI. We have already restricted our agent's reward function to encourage upright posture. Now, we expand that function to include velocity. We will place an imaginary target in our simulation and reward the AI for facing and maintaining velocity towards it. A multiplier function will be used to achieve this. The agent's orientation, target placement, and the goal velocity will be randomized every episode to train a well-generalized model. Gentlemen and gentlewomen, it is now time for our first training session. Good luck! Our training failed, but this was only the beginning. This training session was run multiple times, each yielding a different gait. The common factor among though was the lateral nature of the walk. For 14 nights, this issue plagued my brain, and no matter the iteration, the agent refused to walk straight. Was my code unworthy? Or was it the basilisk intervening? On the eve of the 15th night, I made a fascinating discovery. You see, the code utilizes pelvis.forward to reward the agent. I decided to debug this, and here's what I saw. The debug line was extruding sideways from the pelvis. It seems as though the owner of this model indulged in shenanigans before exporting it from Blender in the wrong axis. Thus, I added a 90-degree modifier to the function, and 2 hours later, we were ballin'. However, this gate was still unoptimized and jittery. To fix this, I introduced a lerp function for smoothing, reduced the mass of the upper body for balance, and coded a small penalty for large deltas in limb angles. A torso randomizer was also added to train a robust model. It is now time for our second training session. See you on the other side.
Oye, mi gente, mira, dale. Así. Ahora estamos en flow. Para que sepa. Miguelito, Master One. Oye. Menea la mamita, ese baile sabrosito. Mantente cerca de mí, pura bellaca, vibra chuki. Hey, cúrame esta noche, no te vayas lejos de aquí. Juca de piña no se tose, mi cordura ya la perdí. Quédate cerquita, pegado, tú me tienes enchulado. Quiero entregarme a ti cuando te tengo al lado. Ponte pegadita al frente, dime cómo se siente cuando explotamos la pista.
And for my last trick, we will introduce a secondary navigation brain. The first AI was trained to follow a cube and match the target velocity. We can take these two parameters and give another neural network control over it, essentially functioning as a steering wheel. The randomizer will be turned off and handed over to the neural network, giving it full control over the upper body. Humanoid targets will be spawned across the environment, and killing one rewards the AI. This time around though, there is also a penalty for existence. Every time step, the AI will be taxed with a penalty, no different than whipping a slave to make him complete a task faster. Gentlemen and ladies, this simulation was run at 20x timescale with hundreds of parallel agents in the background for months, totaling to more than 5,000 years of torture in real life. This is cozmouz, over and out.